Hello and welcome data science and its real world impacts. In this session we will explore basic statistics in data science, foundation of data driven decision making, and hands-on Python exercises. Practical coding for better understanding. Then we have a mean made modes, understanding data averages, and then we have a range, variance, and standard deviation, measuring data spread. Data distribution, how data is shaped and why it matter. And then we have a case studies. Remember, good analysis start with well prepared data. So get ready to think like a data scientist. Let's dive in. What is data pre-processing? Data pre-processing is the process of cleaning, transforming, and organizing raw data to make it suitable for analysis. Why it is important? It removes inconsistencies and error, ensure data is accurate and reliable. Handling missing values, prevent incorrect analysis. Prepare data for machine learning, ensure models work efficiently. Think of raw data like unwatered vegetable from a farm. You can't cook them right away. You need to clean, peel, and cut them first. Similarly, raw data often contains error, wrong or inconsistencies values, missing values, gaps in information, duplicates, repeated entries that distract results. Real world example is Netflix recommends movies based on your watch history. But before using AI, it cleans and organizes this data to remove incorrect or incomplete information. Key steps in data processing. The four key steps. Think of pre-processing like organizing a messy wardrobe before an event. Step 1, data cleaning, fixing error and missing values. Fixes missing values, filing missing sales data with the average. Remove duplicate entries, deleting repeated customers' names. Correct inconsistencies, converting all data formats to one standard. I have two examples, one for the wardrobe, cleaning, remove old damaged clothes, and if it thinks online store with missing order data can't track customer preferences accurately. Step 2, data transformation, normalization, scaling, and encoding. Normalization, ensuring all numerical values are within a similar range. Rescaling customer income data from different countries. Encoding, converting categories into numbers like male, female, or 0, 1. In a car prediction model, we must normalize prices 5,000 to 50,000 or 60,000 so that larger numbers don't dominate smaller ones. In the iron example, messy boardroom, iron and fold them neatly. Step 3, data reduction, removing unnecessary data. Remove irrelevant columns like removing a middle name column from a customer dataset. Feature selection, keeping only the most useful variables. If predicting house prices, we might remove irrelevant data like house color but keep number of bedrooms. Regarding the wardrobe, keep only what you need. That's a reduction. Number 4, data integration, merging multiple data set. Columns combines multiple sources, merging customer purchase history, which website activity logs. Ensure data consistency across systems. For example, a hospital combine lab test results plus patient records plus doctor's notes for better treatment recommendations. And for the wardrobe example, we say integration for combine different clothing items for a complete outfit. So finally, keep step in data processing, data cleaning, data transformation, data integrations, and data reductions, and the subjects of particular data pre-processing. Why is statistics important in data science? Statistics help us summarize, analyze, and interpret data, allowing us to identify a pattern and make informed decisions. In this lecture, we will explore how statistics help us understand data science, identify pattern, and make informed business decisions. Key points. Statistics is essential for data science because it transforms raw data into insight by summarizing trends. It helps businesses in forecasting, customer behavior analysis, and risk assessment. Without statistics, we cannot validate machine learning models, measure uncertainty, or dataset biases. For example, a retail company analyzes customer purchase data to identify popular products. Basic statistics in data science. Key concepts in business statistics, measures of central tendency, mean, median, mode, what is the typical value, variable and dispersion, range, variance, deviation, how spread out is the data distribution, frequency table, probability distribution, how is data shaped. Imagine you are analyzing customer purchase in an online store. Some customers spend $10 and other 500 and a few spend thousands. How do we describe the average spending? Is the mean, median or mode more reliable? This is where basic statistics come into play. Python exercise calculating mean, median and mode. Import NumPy for numerical operations and import SciPy for statistical functions. Salary data set with an outlier which is 2000, this one, and then we have calculate the mean average salary and the sum of all salaries divided by output, and we find the main salary. Then we have a middle salary, calculate the middle value when the stored, and third one is calculate the mode most frequently occurring salary and mode salary, and then we return most common values. So here is the result, mean average sum of all values divided by total count. So mean average salary, mean is 4000 and all the divided by 7, so which is 69,714.29. And but do you think 69,000 is a good representation of the typical score? Because due to this one, we have a different values. This mean is highly affected by the outlier, pulling it away from the majority of the salaries. Mean is useful when data is normally distributed by but is sensitive to outlier. Median value, the midpoint when data is sorted. Since the data has 7 values, the median is the fourth value when stored. So 51,000 is the median, which is a more robust to outlier than the mean. This one, the outlier. The median is the useful when there are extreme values, outlier that distort the mean. Most frequently values, that is mode, the value that appears most often. The mode is the most frequently occurring number since all values only once the smallest value is returned as the default, that is a 40,000. The mean is sensitive to outlier, making it less reliable in skewed distributions. Mode, the mode is useful for category data but less informative in unique numerical data set. And the median one is a more robust to outlier and often a better indicator for central tendency in skewed data. Variability and dispersion. Range, difference between the highest and lowest values, and variance is measured the spread of data point from the mean. Standard deviation, square root of variance, how much data deviate from the mean. Uh, this person measures how spread out data is. If values are close to the mean, the standard deviation is low, like consistent sales. If values vary greatly, standard deviation is high, like stock prices. Example is we have two data store, daily sales, store A, low variations, and store B has a high variations, low variation and high variation. So which store has more consistent sales? So Python exercise, we import necessary libraries. Uh, NumPy also already told you is used for numerical computation. And then we define sales data for two stores, which has a low fluctuations and other has a high variations. Compute deviation for store A, and then standard deviation measure how much the sale deviate from the average. Since store A's sales are close to each other, we expect a low standard deviation. Commute standard deviation from store B is that, and store B sales have extreme high and low. And high standard deviation is expected, indicating more variation in sales. So we print the calculated standard deviation, round it off two decimal places for clarity. So print standard deviation B and A and B. Now explanation of the results. Store A standard deviation is 7.07 and sales are consistent and close to the average. Business implication, the store can easily predict future sales and manage inventory efficiently. Store B standard deviation is 179.16 and sales are vary significantly. The store might need to adjust marketing strategies, analyze peak sales periods, or handle inventory carefully. So simply, if the standard deviation is low, the sales are stable and predictable. If the standard deviation is high, the sales fluctuate significantly, making prediction harder. Handling missing data. Normal versus skew distribution. Normal distribution is bell-shaped, symmetric, high IQ score. A normal distribution means most values are around the mean. Skew distribution is data is pulled in one direction due to outliers. Right skew distribution is salaries, property prices, a very high values rises the mean, and the left skew distribution is exam failures. A few low values pull the mean down. For example, income distribution is in company is right skewed because a few executives earn very high salaries. If a few billionaires are included in salary data, the mean salary may appear high, but the median remain realistic. Why does missing data occur? Data entry errors, mistypes are overlooked values during data collection, sensor failure, incomplete data due to malfunctioning equipment, survey non-responses when respondents skip survey questions, technical issues, system crashes, incomplete data transfer. Missing data is common in real-world dataset and must be handled carefully to prevent destroyed analysis. Deleting missing data works for small dataset but can introduce bias if too much information is lost. Types of missing data. M scar missing completely at random, data is missing without any pattern. MCAR data is generally less problematic because its absence does not depend on the value themselves. MAR missing at random, data is missing in a way that other observed data can explain. MNAR missing not at random, missing data is related to unobserved data itself. MAR and MNR can introduce bias, especially when important information is missing systematically. Impact marketing accuracy. Missing customer data can affect personalized recommendation, reliable customer segmentation. Poor handling of missing values may lead to incorrect targeting. Decision making bias, ignoring missing data is incorrectly can distort conclusions. Methods of handle missing data. Deletion methods. Deletion methods work well for small amounts of missing data, but can lead to biased result if too much data is removed. List-wise deletion remove rows with missing values, and pair-wise deletion remove missing values only in specific calculation. Imputation methods help preserve dataset size but should be used carefully to avoid distorting distributions. Mean, median, mode imputation replace missing data with central tendency values. Regression imputation predict missing values using regression. And KNN, nearest neighbors, use nearby values to estimate missing data. Regression and KNN offers more sophisticated solution but require more computation. Choosing the right methods, listwise deletion simple but reduce data set size significantly. Pairwise deletion keep more data but can cause inconsistencies. Mean median imputation fast but can reduce variability and mask pattern. Regression imputation accurate when variables are correlated. KNN works well for features dataset but computationally expensive. Case study handling missing data at retail corp. The background is retail corp collects customer data for personalized marketing, but missing values exist due to incomplete surveys and system errors. So you can see here this one data is missing, this one is missing, this one missing, and this one missing. So we import pandas library for data manipulation and create the data set with missing values. The customer IDs, there is no missing values. Age, missing age values. Uh, this one and this one. And then annual spending, missing spending values. And then have a preferred categories, and then still there is a category which is uh, missing missing categories. And now we convert dictionary to data frame and display the data set before handling missing values, and that is a missing value. And now we have missing values age column with the median values. This one, median is chosen because age is often skewed distribution. Mean can be affected by outliers, very high or low ages. Using the mediation ensure that the missing value do not distort the overall data distributions. So now I fill the missing values in the annual spending column with the main values. This one, mean is chosen for annual spending because spending data is generally normally distributed. If we use median, we might lose information about overall customer spending pattern. Using the mean maintain the balance of data without skewing results. Now we fill the missing values in the preferred category with the most frequent mode of value. So uh, preferred category. Mode is chosen for category data because it represents the most frequently occurs value. In this case, if electronics appear most frequently, we assume missing value also belong to electronics. This helps maintain consistency in category classification and display the dataset after handling missing values. So now age column, uh, age column missing value were replaced with 32.5 median age, preventing distortion for the outlier. Annual spending, missing value were replaced by 7,300 mean spending to maintain balance. And preferred category electronics missing value were replaced with electronics most common category for consistency. Why not delete missing values? If we deleted missing value, we would lose important customer data. Instant imitation techniques allow us to retain information while minimizing bias. How does imitation affect analysis? If too many values are missing, imitation can introduce error. Using the wrong imitation method, using the mean when the median is better, can distort results. When to use different mutation techniques, mean when data is normally distributed, like spending, median when data is skewed, age, here, and when dealing with category data, product category. Frequency of probability distribution. Understand how frequency distribution help analyze data and transition into probability distribution for deeper insight. A frequency distribution represents how often each value in a data set. It helps identify trends, outlier, and data patterns used in sales analysis, survey responses, and quality control. The higher the frequency, the more common the value in the data sets. A frequency distribution table summarizes the dataset by counting occurrence of unique values. This is useful for understanding common trends and identifying outliers. Businesses use frequency distribution for sales analysis, customer demographics, and inventory management. Let's have Python exercise creating a frequency table using pandas. So first we import pandas as PD, import for data handling, and then we sales data for smartphones. That is the numbers, and creating a frequency table using pandas, and then display a frequency table. Convert frequency table to probability distribution coding and display the probability table. So before conversation, it was the frequency and sales value, and after conversation, sales value or probabilities are changed. Key observations. The frequency table shows how many times each value appears in the dataset. Probability distribution shows relative occurrence proportion of each value. It helps predict future trends based on past data. Why is probability distribution important? It allows businesses to predict future sales based on past trends, help identify the most common values, modes in the data set, and use in risk assessment, customer segmentation, and decision making. Business application. In retail, probability distribution helps determine stocking level based on historical sales. And in finance, it helps the risk assessment and forecasting. Introduction to normal distribution. The normal distribution is one of the most important probability distribution in statistics and data science. Its bell-shaped curve where characterize it, the mean average is at the center. The standard deviation determines the spread of the data. Most real-world data set heights, IQ scores, test results follow a normal distribution. The empirical rule 68-95 99.7 rule states for a normal distribution. 68% of data falls within a one standard deviation from the mean. 95% of data falls within second standard deviation from the mean. 99.7 of data falls within third standard deviation from the mean. Understanding the normal distribution and the empirical rules. First, we need to import necessary libraries for operational numerical operation and generating data for NumPy. Import for visualization, and then we have a for statistical function. Generate data for normal distribution, center of the normal distribution mean, and then standard deviation spread of the data. Already tell generate 100% values evenly spaced between -4 and 4 standard deviation. And then we have a compute the probability of density functions PDF for the normal distribution and create a figure with the specific size for better visibility. Then plot the normal distribution curve and highlight the region under the curve for the empirical rule. 68% of data fall within 1 standard deviation, yellow shaded area, and then 90% of data falls within 2 second standard deviation, orange shaded area, and then 99.7% of data falls within third deviation, red shaded area. And then label and title to the plot of clarity. X-axis represents standard deviation and y-axis represents the probability density function. And then empirical rule in the normal distribution, title of the graph. And then display a legend of explain to highlight area and then show the final plot. So the plot illustrates the empirical rule 68, 95, 97 in a normal distribution. Bell-shaped curve represent normal distribution. This one with a mean of 0 and standard of division 1 and shaded region, yellow one 68% and data within a 1 standard deviation from the mean. Orange 95%, data within second deviation from the mean, and the red one is 99.7, data within third standard deviation from the mean. The majority of the real-world data follow this pattern. If data significantly deviates from the distribution, it may indicate outlier or skewed distribution. Synthetic versus skewed distribution. And the data is evenly distributed around the mean, and the example is normal distribution, bell-shaped curve, already discussed. Key feature, mean is equal to median and then the mode. Skew distribution, the data has one long tail, either right or left, and the types are right skewed, positive skewed, tail extend to the right, higher value. Example, income contribution, a few people can extreme high salaries. And the left skewed tail extend to the left side, lower values. And exam score, yes, most students score high with a few very less score. The left far is a low and the right for the high values. HR analytics, employee survey analysis, and the calculate mean, median, and mode of the employee salaries. Import necessary libraries, and then for numerical operation NumPy and SciPy for statistical function, and define employee salary data in thousands. So the salaries, the value 200 is an outlier, and we mean calculate average salary mean and then we calculate median salary and then calculate mode most frequently occurring salary and then print results. Mean can be influenced by outlier and median is robust to the outlier, and then mode shows the most common salary. And we can see here the mean is influenced by the outlier, but if we compare with the median, that is a 70. So the mean average salary is 81.09. The mean is calculated by summing all salaries and dividing by the total number of employees. The issue is the presence of outlier 200 skew the mean higher than most employees' actual earning. The median salary is 70.0, green one, and the between salaries are arranged in order. It is useful because the median is not affected by outlier, making it a better measure when data is skewed. And then mode salary is a 50. The mode present the most frequent occurring salary. Why is it useful? Because the mode is great of categorical data and finding the most common salary. Sales and marketing customer purchase behavior. Identify if customer spending follow a right skew distribution. So first, as usual, we import necessary libraries, and then we import for the plotting graphs, and then we have for numerical operations. Generate customer spending data right skewed distribution, which is exponential distribution in right skewed, and plot histogram to visualize the skewed data. KDE true at the smooth density curve, and then we have title of the plot, and then we have a x-axis label, and then we have a y-axis label, and then we display the plot. So left plot, orange one, histogram shows a right skewed distribution, meaning most customers spend lower amount, but a few spend significantly more amount. And the right side below one, after applying a long transformation, the data appear most normally distributed, making it easier for statistical modeling. Retail inventory management stock optimization apply for normal distribution to predict product demand. So first import spy for probability function, and then define average monthly demand and standard deviation, and then average demand of products and the standard deviation of demand. Calculate probability of demand within one standard deviation, 68% rule. Then calculate probability of demand with in second standard deviation, 95% rule. And then we have a print possibilities, standard deviation first and second. So here graph representation the normal distribution of product demand based on 68-95-99.7 rule. The below curve represent the normal distribution demand. The black dash, this one, marks the mean 500 units. The orange demand lines in a 400 to 600, and covering approximately 68% of demand value. The red line shows the within the two standard deviation, 300 and 700, covering approximately 90% of demand values. This visualization helps understand stock optimization by predicting product demand fluctuation within standard deviation limits. Finance and risk management, credit scoring, simulate credit score, identify risk levels. So first we import necessary libraries, then generate credit score following a normal distribution for mean, then classify credit score into categories, low risk, and then we have medium risk, and then high risk, and we print category proportions, print low risk, print f medium, and then high risk. And then we have a visualization credit score distribution with risk thresholds, the plot figure 10.5, and then my marks high risk and low risk thresholds, high and different, and then we have labels and titles, credit scores, frequency, etc. And this is the credit score distribution and risk level. uh, Risk category proportions are these are, and then the low risk is 22.7%, which is 750. Medium risk is 73.4, 600 to 749. And then we have a high risk, which is less than 600, which means 3.9%. Healthcare patient diagnosis and treatment trends predict seasonal patient admission trends using normal distribution. So obviously import necessary libraries, and then we define month of the year, January to December, and then simulated patient admissions over 12 months. And that is the numbers of the patient in according to the every month. And then we create a data frame to organize the data. And then we have a plot the patient admission trends, set figure size, and then we have a line chart with markers and highlight seasonal trends, peak admissions and declining trends. And then we have a table labels and titles. Here is the graph showing patient admission trends over 12 months. Below line represent the number of patients admissions per month. Red line highlight the peak admissions and period April to June, and green dash line indicates the decline admissions in September to November. This visualization helps in understanding seasonal trend, which can assist hospitals in resource planning and staff allocation. And now we have a data science applications. Thank you.